Hello everyone, I hope you all are doing great. So today we'll be learning about the conversion of galvanometer into the voltmeter. I hope that you know the basics of galvanometer. Well, the galvanometer is combination of ammeter and the voltmeter. So there are few things that we need to install in the galvanometer in order to either convert it in the voltmeter or the ammeter. In order to convert it in the ammeter, as I have taught you in my previous lecture, how can we convert it into the ammeter? So we use a shunt resistor in that. But in case of am voltmeter, if we want to convert a galvanometer into a voltmeter where it can measure the voltage, so in that case we connect it with a resistor again, but that resistor is known as series resistor that we often show as Rx. So this is the basic thing that we're gonna study today. So before getting started, there are a few diagrams that will help us to understand the conversion. So first of all, this will be a current carrying conductor in which the current is flowing from this direction to this direction. Now we'll attach a resistor parallel to the current carrying conductor. Again, we'll install a galvanometer in the series. This is the galvanometer. We have attached this galvanometer in series of the resistor. Now, when we make up this sort of diagram, this sort of figure in which we are attaching the galvanometer in series, so in that case, the resistor in front of it is known as Rx. This is the resistor, series resistor. The current flowing in direction of the galvanometer or in the direction parallel to the galvanometer, that is known as Ig, as we have denoted it with Ig in our previous lecture as well. This is galvanometer denoted by G. Then again there will be the resistance that is created by the galvanometer, so that is known as Rg. Now let me write it down in detail. We have used few factors. Ig, that is what? That is the total current. The current flowing in this direction is I, not Ig. Keep this in mind. The total current passing through the galvanometer. Okay. Then the second factor that we use was that Rg. This is what? This is the resistance by galvanometer. Then we used again a factor Rx. This is the resistance of series resistor. Now there are few things about the series resistor that you need to know. In the case of conversion of galvanometer to ammeter, we use a low voltage resistor. But in case of the conversion of the series into the the galvanometer to the voltmeter, we will use a high voltage, or you could say the high resistance resistor. There will be a high resistance created by the series resistor. High resistance or high power resistance. This is the thing that you must know. Second thing that is really common for the condition, as I have mentioned the same point in my previous lecture as well, that whensoever any circuit is created in series, the resistors, either the resistor are in the form of galvanometer, voltmeter, bulb, anything that is attached in a circuit, that is known as a resistor. So if any resistor is connected in series, so in that case, the current always in series, I'm talking about series, always remains same, but voltage changes. In the case of the parallel, in the case of parallel, the condition is opposite. In that case, the current varies, but the voltage remains same. Here the condition that we are going to apply is that the I will remain same. That means if we consider Ig as simple I, so that would also work. But here the voltage will vary. There would be a change in voltage. So let's denote that voltage in this whole circumstance as well. Just a moment. Let me remove and make some space for our work. Well, let's get back to the figure once more. Here, we know this fact that current is being applied to two of the situation. First, the voltage is there is a change in voltage where change in voltage in here the resistance. Let's denote that voltage as Vx, and again there will be another change in voltage where this will be performed here. So let's denote that voltage as Vg. So now again we got two more factors. First one is what? First one we have denoted Vx, that is what? Voltage of series resistor. And second we have denoted that Vg, that is voltage of galvanometer. Okay, I hope that these all factors are clear to you. So now we'll move on to the derivation, how we can transfer the voltmeter into the case. Okay, let's once again look into the figure and remove this all mess. Okay, now first thing that we're gonna do here is that first we'll find the total voltage. Can we say this thing that voltage passing by this circuit, or the whole voltage of this circuit, is equal to the voltage passing by the G, and after the resistance of the galvanometer we got Vx. So if we add Vx into Vg, so we get the total voltage of the whole circuit. Applying the same thing, we know this fact that the current, either we are considering current passing through the galvanometer or current passing through the resistor, the passage of the number of electrons would remain same since we have attached it in a series. In the case of the parallel, the galvanometer and the resistor were parallel to each other, so there was a distribution in number of electrons. But in this case the number of electrons is same, but there is change in the polarity. So can we denote Ig as equal to Ix, or we can simply say it I? Okay, now let's put in the Ohm's law to the condition where we have denoted V equal to, let's say that Ig is equal to the current by I and the resistance by G, the current by G and resistance by G, and add it with the current by G, or let's simply say it I. Let's then not create the mess of the G. I into the resistance by the galvanometer. Oh, sorry, the resistor. I hope this thing is clear to you. Now we're not gonna do anything else. We'll simply do some of the calculations since we need to find the value of the series resistor. So we'll make equation accordingly. So can we take I common? And after that we're left with Rg plus Rx. Now here I is multiplying after going there, if we'll divide. So it will be V upon I equal to Rg plus Rx. To find the value of the Rx, can we write it as V upon I minus Rg equal to Rx? Now here is the equation to find out the Rx. I hope that you get it, and thank you so much for watching our video. That's all for today.